For 10 years, the photographs just sat there. Thousands of images from the edge of the solar system, studied, published, filed away. Everyone thought we'd squeezed out every secret they had. Then, a few weeks ago, the man who led the mission looked again. And hiding in plain sight, on the most famous glacier on Pluto, he found something that should not exist. Dark streaks, sharp-edged, fresh, the kind of marks that on Earth mean only one thing: something liquid touched this ice. Here's why that sounds insane. Pluto's surface is nearly 400 degrees below zero, cold enough that the air you're breathing right now would freeze into solid rock. Nothing flows there, nothing moves. That world has been declared frozen solid for as long as we've known it exists. And yet, the evidence now says something has been seeping up from underneath. Recently, maybe even still, right now, while you watch this. By the end of this video, you're going to know exactly what NASA found, how a liquid can exist on the coldest surface we've ever visited, and why this discovery quietly points at something much bigger hiding under Pluto's famous heart. Let's get into it. To understand why this discovery matters, you need to meet the man who made it. Twice. His name is Alan Stern, and for most of his career, he was obsessed with one idea that almost everyone told him was a waste of time: sending a spacecraft to Pluto. Think about the odds he was fighting. Pluto is 4 billion miles away. It's smaller than our own moon, and halfway through the project, astronomers literally voted it out of the Planet Club. Imagine spending decades of your life planning a mission to a planet, and while your spacecraft is on the way, the world decides it isn't a planet anymore. But Stern's mission, New Horizons, kept flying, 9.5 years through the dark. And on July 14, 2015, it screamed past Pluto at more than 30,000 miles per hour, cameras firing, with one single chance to capture everything. No orbit, no second pass, one shot. What came back rewrote the textbooks. Ice mountains taller than the Rockies, blue haze layers stacked hundreds of miles high, and right in the middle, the feature that became world famous overnight: a massive, pale, heart-shaped plain of frozen nitrogen, bigger than Texas and Oklahoma combined. Scientists named the western half of that heart Sputnik Planitia, and even back in 2015, it looked wrong in the best possible way. It was too smooth, too clean, a surface with almost no craters on a world that's been getting hit by space debris for 4.5 billion years. That only happens when something keeps repaving the surface, like fresh asphalt on an ancient road. The mission moved on. New Horizons flew deeper into the dark. The photos went into the archive. The world stopped paying attention, but Alan Stern never did. And a decade later, he went back into those old images, this time bringing something unusual with him, a team that included experts on Earth's glaciers, people who spend their lives studying how ice sheets in Greenland and Antarctica behave when meltwater touches them. And when the glacier experts looked at Pluto's heart, they recognized something they'd seen before, not on another planet, but on ours. Now, before I show you what they found, one thing, because it matters on this channel. Everything in this video comes from the actual peer-reviewed study published July 31st in the Planetary Science Journal and from NASA's own announcement. Both links are in the description. No invented claims, no aliens did it, The real science here is strange enough. If that's the kind of space content you want, real discoveries, decoded, subscribe and hit the bell. Twice a week, we take the biggest space news and break down what was actually found. And trust me, the mechanism behind this discovery, which I'll show you in a minute, is stranger than any clickbait version could be. So what exactly did they see? Zoom into the northern edge of Sputnik Planitia, and the glacier isn't one smooth sheet. It's divided into enormous cells, polygons of nitrogen ice, each one roughly the size of a city. These cells are slowly churning, like a pot of the world's coldest, slowest soup. Warm ice rises in the middle of each cell, spreads out, cools, and sinks back down at the edges. One full cycle takes hundreds of thousands of years. We've known about the cells since 2015. Here's what the new study focused on: the boundaries between them. Running along those boundaries are dark markings, two kinds: thin, sharp, narrow streaks, like someone dragged a pen along the cracks, and wider, softer, diffuse patches, like ink that bled into paper. And here's the detail that changes everything. Those markings are exactly what glacier scientists see on Earth when meltwater wets the surface of an ice sheet. When liquid touches ice, two things happen. The ice grains grow larger, which makes the surface reflect less light, and the liquid can carry fine dark particles and leave them behind. Either way, the result is the same. Wet ice looks darker. On Greenland's ice sheet, you can trace exactly where meltwater has been just by following the dark stains. The markings on Sputnik Planitia follow the cracks with sharp, clean edges. The team ran through the boring explanations first. That's what good scientists do. Could sunlight alone darken the ice that way? Too weak, and it wouldn't make sharp lines. Could it be dust settling from Pluto's haze? That would fall everywhere, evenly, not trace the crack network like a map. The explanation that fit the pattern was the one nobody expected. These boundaries are being wetted. Occasionally, temporarily, but recently, by a liquid rising up from below, on a world where liquid was supposed to be impossible. And one more thing, the study points out that this surface is young, probably less than 1 million years old. In space terms, that's not history, that's this morning. Whatever is doing this isn't some ancient, finished process. Pluto is doing this in its current era, possibly today. Okay, so how can anything be liquid at 400 below zero? The answer is not water. Let me be completely clear about that, because this is where sloppy versions of this story go wrong. The liquid here is nitrogen, the same stuff that makes up most of the air you're breathing, but on Pluto, it plays a completely different role. Up there, nitrogen freezes solid and behaves like rock. Entire plains are made of it. But nitrogen has a secret. It doesn't need much of a push to melt. And that push, the study suggests, comes from an idea called basal melting. Basal meaning at the base, at the bottom of the glacier. Here's the mental picture. Sputnik Planitia isn't a thin sheet of frost. It's a glacier, possibly several miles thick, sitting inside a huge basin. Now stack up the physics. First, pressure. Miles of ice pressing down on the bottom layer, and pressure lowers the melting point. Squeeze ice hard enough, and it wants to become liquid. Second, heat from below. Pluto's rocky core still holds radioactive elements left over from its formation, slowly decaying and releasing warmth, the same process that helps keep Earth's interior hot. feeble by our standards. But it doesn't need to melt rock. It only needs to nudge deeply buried, pressurized nitrogen across the line. At the bottom of that glacier, in the dark, under miles of ice, liquid nitrogen, a hidden layer of it, sandwiched between the frozen surface and the warm rock below. And liquid under pressure does what liquid under pressure always does. It looks for a way out. The convection cells provide one. Their boundaries are the weak points, the seams of the glacier, cracks that reach down deep. The study's model suggests liquid nitrogen forces its way up through those cracks, reaches the surface, and briefly wets the ice along the boundary before freezing or evaporating away in the near vacuum. A flash flood in slow motion at the coldest place we've ever photographed. If you want an Earth comparison, we actually have one, and it's one of the strangest places on our planet. In Antarctica, buried under 2 miles of ice, there's a body of water called Lake Vostok, sealed off from the sky for millions of years, kept liquid by pressure and the planet's inner heat. Pluto may be running the same trick, different liquid, same physics. Which means the coldest known surface in the solar system has plumbing. Now zoom out, because this is where the discovery gets bigger than one glacier. First, if nitrogen is melting at the base of Sputnik Planitia, that's independent evidence that Pluto still has internal heat. That matters, because for years, scientists have suspected something far more dramatic. A deep ocean of liquid water, buried maybe 100 miles down beneath the ice shell. Cracks in the crust, the way the heart sits on a gravity anomaly. Several clues point that way. This new study doesn't prove that ocean, but a world warm enough to melt nitrogen at a glacier's base is a world where a deep, buried ocean stops sounding crazy and starts sounding likely. Second, Pluto is probably not the only one. Neptune's moon Triton, where Voyager 2 photographed actual geysers erupting, has nitrogen ice. The dwarf planet Eris, out beyond Pluto, has it too. The same basal melting trick could be running on worlds all across the outer solar system. We may have just found the first example of an entire category of activity no one knew existed. And third, my favorite fact in this whole story, more than half of Pluto has never been mapped in high resolution. New Horizons saw one side in one flyby on one afternoon in 2015. Everything in this video comes from that single glance. The other half of the planet is still, right now, a blank page. Before we wrap up, let's do what we always do on this channel. Let's stand there. You're on Sputnik Planitia, northern edge. The ground under your boots is nitrogen ice, hard as concrete. The sun is up, but up means a brilliant point of light, 1,000 times dimmer than home. Bright enough to cast your shadow, too weak to warm your face. The plain stretches to the horizon in a pale, ghostly cream color, utterly silent, utterly still. Ahead of you, a crack, a boundary between two ice cells running like a seam to the horizon. And along that seam, the ice is dark, a stain meters wide, tracing the crack as far as you can see. You crouch down. The surface there has a different texture, the grains coarser, the shine deeper, like pavement after rain that fell an hour before you arrived. Nothing moves, but you know what this is. You're looking at the fingerprint of a flow. Somewhere beneath your boots, maybe miles down, there is liquid, in the dark, under pressure, waiting. It was here, It reached the surface. It touched this exact spot, geologically speaking, moments ago. And the strangest thought of all, on the coldest ground humanity has ever seen up close, you might just have to wait long enough, and something would come seeping up through the crack in front of you. The frozen world at the end of the solar system is not finished. It's active, it's alive, not in the biological sense, but in the way a glacier is alive, the way a volcano is alive. Pluto has a pulse. We just found it. Now, the honest fine print, because on this channel, we always do the fine print. Nobody filmed liquid flowing on Pluto. What the team found is the strong signature of recent wetting, backed by models that show the mechanism works. The study itself says the features may be wetted. That's the accurate wording. It is the first evidence of recent liquid on Pluto's surface. It is not liquid water, and it is not a sign of life. What it is a frozen world caught doing something we thought frozen worlds don't do. So here's my question for you. NASA has no funded mission to go back to Pluto. And remember, half the planet is unmapped. If you had the budget for one mission, do you send an orbiter back to Pluto to watch these flows happen, or push on to a world we've never visited at all, like Eris? Pluto, or the unknown? Drop your answer in the comments. I read every one. If you learned something, the like button genuinely helps this channel get seen. Subscribe for new discoveries every Tuesday and Friday. And if you want to know what might be hiding under that ice shell, the buried ocean I mentioned, that full story is coming in an upcoming video, and it's even stranger than this one. Thanks for watching Voidline. I'll see you in the next one.